Hi, my name is Charlie, and you can also call me the Guitar Boy. Today we are going to be doing chemistry, and what we are going to be doing today is related to our last video, which is relative mass of substances. But today we are going to be doing calculations in relative mass, the calculations of relative masses of substances. That is what we are going to be doing today. And if you have not watched that video, it will be good for you to go back and watch that video before coming here. Calculations under this particular topic are very simple. So however, you still see them in WAEC, in JAMB, and in NECO nursing exam. So you see them there. So in our last video, we said it was calculated that the relative mass of oxygen was 16, the relative mass of nitrogen is 14, the relative mass of carbon is 12, the relative mass of hydrogen is 1, the relative mass of sulfur is 32. So these are relative masses. When they ask you what is the relative mass of oxygen, these are the relative masses. If you watch that video, I believe you won't have issues with what you are having here. You won't have issues with what you are having here. So I want to quickly talk about isotopy, and in that particular video I introduced isotopy, and I will still talk about it in some other video for you to understand it. Let me just say something about it here. You know, isotopy is a phenomenon in which a given element has the same proton number but different neutron number, and that will bring about a variation or changes in their mass number. Okay, now what it means is that when you have, for the example of substance that possess this isotopy is what? Chlorine. Chlorine has two types of chlorine. There are two types of chlorine, but mind you still hear the name chlorine. Why? I will tell you. Now, chlorine has two isotopes, which is chlorine 35 and chlorine 37. So whenever you have chlorine, like, oh, what are you carrying? I'm carrying chlorine. These two that just note that the chlorine you are carrying has these two inside of it. Whenever you are carrying your chlorine, just note that the chlorine you are carrying has these two type of it. Usually this one usually have the percentage abundance of what? 75%. This one is always more than this. This one has a percentage abundance of what? 25%. That is what it means. So this chlorine has a percentage of 75. This one has a percentage of 25 whenever you have chlorine with you. So that is what isotopy means. You see here we have chlorine 35. This is the relative mass of this particular chlorine, type of chlorine 35. This is the relative mass of this particular chlorine 37. Why is their relative mass is different? Or since they are the same element, are they not supposed to have the same relative mass? Yes, they are supposed to have. However, it is not so here because of the isotopic phenomenon. The reason why they have different masses here is because their proton number is the same. Their proton number, which is their ID, if you watch our previous video, you will know what I mean. Their proton number or atomic number, which is their identity number, is the same. That is why you were able to still call them chlorine. So that's their ID. Hence, you can call them chlorine. But their neutron number are different. Now, when you are talking about the mass of an atom, it is proton number, proton mass, the mass of proton plus the mass of neutron. That is when you plus these two together, that is how you get all these things, these masses here. But this one now, for the both of them are the same. This neutron number are different. So that is how you the isotopic phenomenon works. Okay, so they have the same proton number but the same neutron number. You can be asked in examination, the isotopic element have, which of this is correct? Isotopic element have the same proton number, the same neutron number. A, that B will not be the same proton number, different neutron number. C will not be the same neutron number but different proton number. The answer is apparently what? B. They have the same proton number but different neutron number. And if that be the case, that is the reason why their mass numbers are different. That is the reason why their mass numbers are different. So in this case, if I now ask you now, what is the relative mass of chlorine? You see that this chlorine has a relative mass of 35. This chlorine has a relative mass of 37. What will you not tell me? You will not be able to tell me that it is 35 because I have another chlorine that has 37 just as this one has 35. So you won't be able to tell me that it is what? 5 or 37. So because of that, because they have two isotopes, you now look for the average mass of the two isotopes. This usually they set it in JAMB, WAEC, and NECO. They will ask you, they give you the isotope, ask you to calculate the relative mass of the substances. After giving you the isotopes of the different substances, they will ask you to calculate the relative mass of the substance. In this case, if you want to calculate the relative mass of these substances, you must have their percentage abundance and also have their masses, the relative masses of each isotope. So how do you do that? You come here, you say this one, it will not be what? The solvings will not be what? The solving will not be what? 35 times 75 times 35 plus, look at it, the percentage abundance times the relative mass of the first one all over 100 plus the percentage abundance times the relative mass of the second one, which is what? 25 times 35 times 37 all over what? 100. Okay, now in that case you look for the LCM of these two. When you look for the LCM of these two, you have, this is the LCM. Okay, so before then, when you multiply this one will give you what? 2625 plus this one, when you multiply it will give you 925. Okay, it will give you 925. This one will not be what? If you plus the two together, they will give you 3550 divided by this 100, which will not give you 35.5. So this is how you calculate the relative. This is the relative mass of chlorine. So if anybody asks you for the relative mass of chlorine, this is what you tell them. So you have looked for the average mass of the isotope to calculate the relative mass that you cannot totally tell anybody that the relative mass of chlorine is. Okay, so this is how you calculate the relative mass of chlorine. We are going to use one more example here from one JAMB question here to as an example again, plus this one. So look at this JAMB question 2014. You can go and check it from your JAMB pack 2014. We don't have time to write question on the board. 2014 JAMB question on isotopy. So look at the question. It says a silicon containing or has 92% silicon 28. This is one isotope, and it also have 5% silicon 29, and it also have 3% silicon 30. Now calculate the relative atomic mass of the silicon. Calculate the relative atomic mass of the silicon. How do you calculate the relative atomic mass of the silicon? The same thing you did with that former one. Just come here, use what you have here to times this one. You say 92 times 28 all over 100 plus 5 times 29 all over 100 plus 3 times 30 all over 100. When you look for the LCM of, since they are the same thing, the LCM will be 100. So when you times this, 92 times 28 will give you 2576 plus 5 times 29 will give you 145 plus 3 times 9 will give you 90. So when you add everything together, it will give you, when you add everything together and divide it will give you 28.11. So this is the answer to this question. So you see, as you can see, the solution to this question is very simple. I repeat again, if you have different isotopes, you wouldn't know the relative mass to tell anybody if anybody asks you about that particular element, because they have different type of that same element because of isotopy phenomenon. So in order for you to have one particular relative mass that you cannot tell anybody, you have to look for the average mass of the isotope, or the isotope together. How do you look for the average mass? You multiply the percentage abundance with the relative mass of the first isotope, divide by 100, plus the percentage abundance of the relative mass of the second isotope, divide by 100, plus the percentage abundance of the third isotope times the percentage abundance of the third times the relative mass of the first, divide by this. The reason why you have 3 here, the first one we just have only 2 values, because chlorine has two isotopes. Chlorine has 2 isotopes, but this one has 3 isotopes. If they are up to 4 isotopes, for instance, you will now multiply the percentage continuously like that until all the isotopes are incorporated into the calculation. So from there, when you do your calculation, you have your answer like this. Okay, it's very, very simple, and it's very simple. So this is how you calculate the relative mass of isotopic substances. So let's move on to few other calculation, then we round off with this particular video. Now there is another aspect which is very, very crucial. Again, if, for instance, when they ask you to calculate the relative mass of a compound, the chemical compound, what is the relative mass of CO2? The CO2, the relative mass is, the relative mass of carbon is 12. Carbon is equal to 12, oxygen is equal to 16. So if oxygen is 16 and you have 2 oxygen here, so since it is 2 oxygen, you say times 2, which is equal to what? 32. So the relative mass of this compound now, which is carbon 4 oxide, will now be what? That's relative mass of carbon 4 oxide of CO2 will now be equal to 12, which is this carbon, 12 plus 32, because you are plussing everything together. 12 plus 20, that's 44. So since it is a relative mass, you don't need to put gram here because it does not have unit. Relative mass does not carry unit. This is how you calculate. So you come here, if you are given any compound, they ask you to calculate the relative mass of the compound. What is the mass, the molar mass of the compound? We'll talk about molar mass later when we enter mode. So what is the relative mass of this compound? We all say, okay, I know carbon is 12, oxygen is 16. Okay, since we have 2 oxygen here, 2 times 16 plus 12, then you add everything together, 12 plus 32, you have your answer. So imagine you are also giving something like this. You are also giving something like this for, let me say, can we say sodium sulfate? Sodium sulfate, SO4. Sodium sulfate. Yeah, sodium sulfate. This is the formula for sodium sulfate. If you have something like this, they ask you to calculate the relative mass of sodium sulfate. What do? You know that sodium is 23. Okay, the relative mass of sodium is 23, and you say times 2. You have 2 sodium here. You see 2 here. So the relative mass of sulfur is 32. Okay, the relative mass of oxygen is equal to 16, but you have 4 oxygen here times 4. So when you plus everything together, just as we did in that previous one, which is equal, will now be relative mass of Na2SO4 is equal to, this times this will give you 46. Sorry, this one is sodium, not nitrogen. This one is sodium. So this one will give you 46 plus 32 plus 16 plus 16, 32 times 2, that's 64. So when you plus everything together, press your calculator, press everything together, you have your answer. So whatever you have here will not be the relative mass of this. So the thing is that whenever you are given the relative mass of compound, just plus the relative mass of the various number together, as well as considering the number of atom of that element in that compound. So like this one, sodium has 2. We have 2 sodium. We times it, the relative mass of sodium times 2. This one we have 4 oxygen. We times the relative mass of oxygen, which is 16 by 4. So we now add everything together to give us our answer. When you press your calculator, I don't have calculator here. Okay, let's try. I don't want to stress myself for that. You press your calculator, you have your answer there. That's how you calculate the relative masses of substances. Let's calculate the relative mass. If you are also asked to calculate the relative mass of sulfur 4 oxide, SO2, the relative mass of sulfur 4 oxide. Sulfur, for instance, have the relative mass of 32. Then oxygen has the relative mass of 16. Since we have 2 oxygen, because you see 2 here, this is oxygen. It means that this oxygen is 2. So oxygen will not be what? Since it is 2, it will not be what times 2, which is equal to what? 16 times 2, which is 32. So therefore, the relative mass of SO2 will now be equal to this plus this, which is 32 plus 32, which is equal to 64. This is the relative mass of sulfur 4 oxide. So this is the end of this class. We are going to stop here. I hope you understand this, because this is just the basis. There are other calculations later. In short, calculations in chemistry, especially in this level, is very simple. It's very simple. But what is difficult there is the chemistry behind the calculation. If you don't understand the chemistry behind the calculation, you keep on having problem in chemistry. So that is why I am taking time to explain some certain terms to you before I move on to calculations, because calculation is nothing at all in chemistry. Calculations for this level is not difficult. For WAEC, JAMB, POSIT-TME, and NECO, calculations is not difficult. What is there is the theoretical aspect. You need to understand it clearly for you to be able to tackle a problem here in chemistry. Thank you so much. And if you are in Edo State, you are close to Belisima Junction. If you are in Edo State, you are looking for physical classes, we